Okay, so this is part 3 of these videos on different forms of quadratics. So this is what we did in the last video, 2 videos, and if you haven't seen it, you should go see it. But we're gonna do another example, and we're gonna do each form separately, and we're gonna find the same. You'll find the same answers, right? And to show you that you'll get the same answers. But when you do the practice, you're not going to be given all 3 forms. You're only going to be given, for example, in standard form, or you're going to be given it in vertex form or in factored form. So it's important to understand that you can find all of these things when it's given in either one of these forms. So this one is standard form, right? It's ay equals ax squared plus bx plus c. This one's in vertex form, y equals x, well, a x minus h squared plus k. And this one, so I'll write the standard vertex. And this one's in factored form, which is y equals a x minus h, oh no, x minus m x minus n. And if you were to factor this out, you would get this. Now, how do we find, let's do standard form first. I'll even zoom in so we don't get distracted. So if we're given this function here, how do we find the vertex? So this was the first thing we learned when we did standard form. So let's identify first what A, B, and C are. A is, you see this negative right here? This is really a negative 1x squared. So A is negative 1. I'll point that here. This is a negative 1. B is 2, right? And C is 3. Negative 1, 2, and 3. How do we find the vertex? So the vertex is, you have to first find, well, let's write it here. First, find the axis of symmetry, which is that line that goes in the middle. So it's x equals negative b over 2a. So negative b over 2a. What is b? B is 2. And what is a? Negative 1. So we have negative 2 over negative 2, right? 2 times negative 1 is negative 2. So I have negative 2 over negative 2. So negative 2 over negative 2 is 1. So we have x equals 1 as our axis of symmetry. But then we need to plug in the axis of symmetry. So I plug it in to this function. So I have y equals negative x squared plus 2x plus 3. And I plug in this value into here. So I plug in 1. And so I get y equals negative 1 squared. So it's negative 1 squared is 1 plus 2 times 1 is 2 plus 3. So I get 2 plus 3 minus 1, which is 4. So my vertex is going to be, final answer, is going to be 1. This is y equals 4. So my final answer is going to be 1, 4. Okay, so there's our vertex. Now, what are my x-intercepts? So how do we find the x-intercepts? And again, if we go back to our chart, it is 2 ways, either factoring or the quadratic formula. So I'm going to go by factoring because I think that that's the easiest method, but you are more than welcome to use a quadratic formula. You will get the same answers. So again, my function is y equals negative x squared plus 2x plus 3. Now, I'm always going to factor this a value out if I can. Remember the GCF. So I'm going to factor out that negative 1, and I'm going to have x squared, if I divide everything by that negative 1, minus 2x minus 3. Remember that your taking out the GCF or a common factor is the same thing as is the opposite of doing the distributive property. So if I distribute this back out, I should get the same thing. Now I get negative 1, and I'm going to factor it. So I have x squared minus 2x minus 3. So 1 multiplies to negative 3 and adds to negative 2. Well, I know it's going, 3 is prime, so it has to be a 3, and it has to be a 1. But it's negative 3 times positive 1 because negative 3 plus 1 is negative 2. And then I use my zero product property. And so I get x minus 3. Remember, we are setting this equal to 0. Y equals 0 for x-intercepts. X-intercepts, y equals 0. So I set my y equal to 0. So I can set, this does not matter when we are solving. It makes no difference. So x minus 3 equals 0 and x plus 1 equals 0. And so I add 3, x equals 3, and then I subtract 1, right? It just goes away. So x equals negative 1. So my roots are x equals 3 and negative 1. And my x-intercepts are 3, 0, negative 1, 0. Remember, different format for different words. Okay? Y-intercept. This is the easiest thing because in standard form, it is given. It is basically given to you, and it is your C value or 0C, right? So it's going to be 0, and my C value is 3, so it's going to be 0, 3. And my minimum or maximum value is going to be right here. It is the Y value of your vertex. So the Y value of the vertex is 4 here. So it is, now the question is it a minimum or a maximum? So this has to do with if it's concave up or concave down. So this is a good review. Our concavity, right, quote unquote concavity, is going to be, and you know what, I should write this down. I should make a whole thing on this. Let's see. Can I do that? Table. Insert column? No. Insert row below. Yes. Concavity. So, is it concave up or down? So remember, if A is greater than 0 or positive, it is concave up. And then, let's write it. And then if A was less than 0 or negative, right? If your A value is negative, it is concave down. Okay, so that's, oh no, that just ruined everything. It's all right. You guys get the point. Okay, so concavity, is this concave up or down? Well, what is A? A is negative 1. So that means it is concave down. Concave down. So meaning it looks like this, meaning it has a minimum or a maximum. It has a maximum value of, and again, it's the Y value. So it's maximum value of 4. So let's graph this bad boy. And it's just going to be a rough sketch, but when you do practice problems, it's going to ask you to graph it. So let's get all of our information. My vertex is 1, 4. So here's 1, 1, 2, 3, 4. 1, 4. Then I have my y-intercept is 3. And I can mirror that. Remember, mirror points are a thing. Boom, boom. And my x-intercepts are 3 and 1. 3 and -1, not 1. And there you go, 5 points. Boom, boom, boom. Okay. Now let's do it in vertex form. So we have vertex form. We need to find the vertex. Given HK, right? So, and a +4. I'm like, wait a second, what happened here? So, +1, +4, right? Because it's the same thing as this and the opposite of this. No, opposite of this, same thing as this. I'm not okay. Now, roots, zeros, root/zeros, and x-intercepts. So we got to find the roots. So you're going to use the square root property here. Let's zoom in and go here. So square root property. So, and I'm going to set what equal to 0. I'm going to set y equal to 0. So y equals 0. So I set y equal to 0. So I have 0 equals negative x minus 1 squared plus 4. So first thing I'm going to do is subtract 4. So I'm going to get -4 equals negative x minus 1 squared. Then I'm going to divide by -1. So I get 4 equals x minus 1 squared. So here's where I'm going to take the square root, but plus or minus. So I get, and I'm going to write it up here, plus or minus 2 equals x minus 1, and then I add 1, and I get 1 plus or minus 2 equals, and when I split it, 1 plus 2 is 3, and 1 minus 2 is -1. 3 and -1, which is the same thing we get over here. Next, we need to find the y-intercept. Now, the y-intercept, you just set x equal to 0. So I have y equals -0 minus 1 squared plus 4. So I get -0 minus 1 is -1 squared plus 4. Now here's where you don't want to make this mistake. -1, this doesn't become a +1 because PEMDAS, my order of operations, tells me to square it first. So I'm going to square it first. So I get -1 squared is +1 plus 4. So then I get -1 plus 4 is 3. So y equals 3, which is the same thing we get here. And then everything else from here down is the same information, right? You use all of this information right here to get all of this. So I'm not even going to go through that, but keep in mind, you still have an a value here, right? This a equals 1 is there, it is there, or -1 is there, and there. So you can know your concavity on any quadratic function that's given to you just by, in any form, just by looking at what the a value is. So you know if it has a maximum or a minimum. And then we have the same vertex, so it's going to have the same maximum value, and it's going to have the same graph because it has all the same information. And then if it's in factored form, you basically, well, let's start over. So let's go with the vertex. So we have the vertex, which is not given, right? But in factored form, I always recommend to find the given information first, right? So factored form, the easiest thing to find is the roots. So I'm going to say given with 0 product property. So we take it, we still have to set y equal to 0. So we have 0 equals x negative, but the negative is really not important here, but negative x minus 3 and then x plus 1, x equals 3 and x equals negative 1, right? This is the same step as over here, but it's fine, right? So we have 3 and negative 1. Now you need this information to get your vertex. Again, I stress it, you can FOIL it if you want, but I'm showing you how to do it without getting it back into standard form. So if my x-intercepts are from -1 and 3, and I know my axis of symmetry is in between them, what value is in between 3 and -1? Well, there's 4 units in between. So that means that if there's 4 units in between, if this is 4, right, then this is going to be 2, and 3 minus 2 is going to be 1. So x equals 1, I know, is going to be my axis of symmetry. Okay? So then I just plug that in. So now I have y equals negative, so I plug it in, plug it in, plug it in. Plug it in. So I have negative, and remember, this is being multiplied together. So it is 1 minus 3, and then 1 plus 1. So I have negative 1 minus 3 is -2, and then 1 plus 1 is +2. So -2 plus, so it's -1 times -2 times 2, which is a +4. So my final answer is going to be x equals 1 and y equals 4, which is the same answer we've gotten across the board. We already found our x-intercepts, and our y-intercept is just plug in x equals 0. So we have y equals negative. We have -3 here and +1 here. So I'm going to plug 0 in. And we have negative 0 minus 3 is going to be -3 and then +1. So we have negative, this becomes a +3 and then times 1. So it's 3. So it's 0, 3, which is, again, the same thing we've gotten across the board. And this is all the same thing. Now, the last thing I want to say is, like, as we look at this big picture, because it looks a little really messy, but when you're graphing this and when you do your work on it, especially on Khan Academy, you will notice that you only need your vertex. So you need your vertex, definitely. So that's not really negotiable when you're graphing them. You need your vertex, but you also need one other point, right? So you have a whole assignment that asks you for your vertex and your roots. So you definitely need to know how to find that. But the reason that your y-intercept is really important here, especially for your Khan Academies, is that you need your vertex and you need one other point. Now, for vertex form and for factored form, it might be easier to find your roots and plugging it into your roots. But for standard form, you can use your vertex and your y-intercept. So make sure you know how to find all these things in order to graph it, in order to compare it, in order to do all that. And this is your graph. These are all the same. And let's just verify. We have 1, 4, we have 3, we have -1 and 3 as our x-intercepts. And there's our mirror point that we graphed, 2, 3. Oh, look how pretty it is.